Greetings out there, one step further in our adventure of advanced SQL. This will be a bit different, this video, because it will entirely introduce syntactic sugar. So nothing that we'll see in the next few minutes really adds to what we can already express with SQL, but we add convenient shortcuts or idioms, if you will, that make it easier to express recurring operations, in this case, particular grouping operations on data. And you will see that very, very brief and very sweet sugar syntax has been introduced to support you when it comes to the analysis of multi-dimensional data. And to properly demonstrate this, let's switch from the playground table T to a new table that I brought with me here and that you can see on the slide already. It's the prehistoric table. It's a table of prehistoric animals. In the right-hand column, you will find 8, or actually it's 6 because 2 of them are null, species of prehistoric animals that we have collected here. And the database folks would refer to this particular column as the fact column. We are collecting facts about these prehistoric animals, and the properties, the interesting data that we are collecting about these prehistoric animals has been organized in so-called dimensions. In this case, it's 3 dimensions: whether the animals are mammals or reptiles, whether they are herbivores or carnivores, so plant eaters or meat eaters. A true entry here means that the species, that particular animal, is a plant eater, a herbivore, and whether these animals are 2-legged or 4-legged. And you can see that this is just a simple integer in this legs column here. So this is a table of facts about these species organized into 3 different dimensions. So please don't make me read and pronounce the names of these species here. Let's see whether the table speaks the truth. Saber-tooth, I think I can recognize that. That's a 4-legged carnivore, and it's a mammal. Okay, I think I buy that. All right. Or a velociraptor, I know that from Jurassic World. That's a 2-legged carnivore. Okay. And it's a reptile. Yes, I can buy that. That's fine. The table also says, hey, there are no 4-legged carnivores that are reptiles. At least this table doesn't know anything about these. Okay, so be it. Okay, so that's the data we are going to play with. And we will now perform analysis of this data. And analysis in this case, and for the next few minutes, shall mean the grouping of these species, of these facts, by different dimensions, by different criteria, and then performing aggregation like counting or just enumeration, but you can imagine any computation to be performed there. Some arithmetics, some interesting statistical analysis, for example. All of these aggregates exist in SQL. Here in the upcoming examples, we will just enumerate all the species that belong into a particular group of animals. Okay, and to have a proper and deep analysis, we will have to perform many group bys. We want to classify the animals with respect to many dimensions, to many criteria. So we will normally we would find ourselves specifying grouping queries with different grouping criteria, again and again and again. And SQL provides syntactic sugar to make this a bit easier. And the first syntactic sugar I want to show you here is the so-called grouping sets. Okay, so this is a normal select from where block with a group by clause. But instead of a comma-separated list of grouping criteria, I just specify this keyword grouping sets and a parenthesized list of sets of grouping criteria. So each of these GY is actually a parenthesized set of column names or of grouping criteria. And what SQL will perform for me is actually will expand this simple query into n individual group by queries. You see I've specified n such grouping sets here. And each of these individual queries, let's call them QI, will be a normal vanilla group by query that uses the grouping criteria specified in GI as the grouping columns. Okay, so this is perfect and very compact syntax for a much larger query in which I would use n individual group by clauses and n individual group by queries, which I would then have to glue together using union all. We have just seen union all in the previous video. This is a much more compact notation. Of course, the grouping sets construct has to take care about the validity of the select clause expressions here. If we are grouping by particular criteria, only these criteria may occur as non-aggregate expressions in the select clause here. All other non-aggregate expressions would be invalid here, as we've seen, as we've talked and introduced the group by construct. This is taken care of by SQL here automatically. So any expression in the select clause that's a non-aggregate expression is automatically set to null for us if it doesn't occur as a grouping criterion in a particular grouping set. So that's many words to specify something really, really simple. So let's switch over to the terminal and then see that in action, and most of the stuff that I've just tried to explain here will become immediately clear, I hope. Okay, so here we go. So this is the Scratch database. Currently there's only the playground table defined there. Let's change that and add the prehistoric table to that. So this is the schema for the table. And there you go. And these are the 8 rows. The 8 rows that we've just seen. It contains the saber-tooth and the velociraptor and all the other cool prehistoric animals that we wanted to analyze. So let's add them to the database, and let's see table prehistoric. Okay, there you go. The 8 rows, the mammal, the reptiles, their classification by herby or carnivore, 2-legged or 4-legged, everything is there. That's fine. Okay, so let's now analyze this data according to all 3 dimensions. So let's separate the mammals from the reptiles, and that would mean a grouping by criterion class. But we would also like to see a separation by being, are you a herbivore or carnivore? And this would be, of course, a classification, a grouping according to the herbivore column. Let's also partition the animals into the 4-legged and the 2-legged species. And of course, that would be a grouping by the legs column. All of these dimensions, all of these partitions would be interesting to me in my analysis. So I would perform all 3 grouping queries and would have then collect all of the results using a union all keyword, the back operation. But I could also use the grouping sets, syntactic sugar, and have SQL perform this in-depth analysis for me automatically. So as you can see here in the select clause, I'm using class, herbivore, and legs here as non-aggregate expressions in the select clause. So when we group by class, it's perfectly fine to mention the class and select clause. It will be constant in each of the constructed groups. But herbivore and legs at this particular point would have to be set to null, and that's what the grouping sets automatically does for us. It's the same, for example, for the legs column. If we group by legs, then we may specify legs here, but have to set the other two to null, and that's what the grouping sets construct will automatically perform for us. regarding aggregation and analysis, well, we are just collecting. We are just collecting the names of the species in a comma separate list here so that we can see who's been classified as what. So we could, of course, perform cool statistic analysis here, but let's not do that here. We are just collecting the animals. So let's see what the result is like. Okay, so this is the result, and as you can see, it consists of 3 parts. This would be the first part, in which a separation, a partitioning, a grouping by class has been performed. The first dimension that we requested here in the grouping sets. Okay, and the separation into reptiles and mammals has delivered this particular listing of species, and I think that's correct. This requests a categorization, a grouping by herbivore or carnivore, and we find that here in the second part. Into the carnivores and into the herbivores, and you see that automatically legs and class, the reptile mammal indicator, has been set to 0 here for us, but it's a grouping set. Very convenient. And the 4-legged and the 2-legged animals is the third dimension in which we did the grouping, and you will find the listing of the species here in the last part of the result. So this is a 3-fold analysis according to the 3 grouping sets that we have specified here in the grouping sets specification. Okay, perfect. Because this is syntactic sugar, we could have performed this on our own without using the new grouping sets construct. We would have to perform 3 individual group by queries and use 2 union all operations to glue everything together. And just to convince you that this is actually what can be done, I've specified the same query without using syntactic sugar here below in the editor. So analysis by the first dimension, the class dimension, would be based on a simple vanilla group by according to column class. The other, the herbivore and legs columns, would have to be set to null, and we would have to take care of that. Let's do that. Everything else remains the same. This is 1/3 of the query we need to specify it. We would need to use union all to glue this to the grouping by the second dimension, and use another union all to glue this to the grouping in the third dimension. That's quite a SQL query, and it's a good thing that there is the grouping sets syntactic sugar, but let's make sure that this indeed computes the same results. Let's see. Long query, but the same result. You see the same grouping and the same categorization of species according to the 3 dimensions here. Perfect. There's even more syntactic sugar that saves us from specifying extensive group by queries that are all glued together with union all. And another such syntactic sugar is the rollup keyword. The rollup keyword is also used in place of the grouping criteria that you would normally specify after a group by. So the syntax would be group by rollup, and then a list of grouping sets in parentheses. And again, what this will do for us is expand and save us from explicitly specifying a much larger grouping query. In this case, the rollup will expand into this particular grouping sets. Okay, in this particular grouping set. So this rollup will perform 1, 2, 3, actually n plus 1 groupings for us. Okay, the rollup operation performs a sort of hierarchical grouping. It will start at the root of the hierarchy with the empty grouping set, and we will see in a minute what grouping by the empty grouping set will mean. You can see that the hierarchy arrow points down here. In the graphical notation, the hierarchy arrow points upwards, so at the top of our hierarchy there is the list of all animals in our in our table. So this is the root of the hierarchy. Grouping by the empty set means reproduce all the prehistoric animals, no matter any dimension. So everything will be thrown into one pot here. This is all the prehistoric animals. This is always the root of the classification hierarchy. Okay, then we look at G1, and G1 would be the first criterion that we use to have a somewhat finer granularity partitioning of the facts that we stored in our table. So if class would be the first criterion, the first dimension in which we want to partition our animals, then this would extend the hierarchy like this. So from the root of the hierarchy, we would separate into by class. So we would separate into the mammals and the reptiles. Okay, so that would be a bit finer classification. If G2 and G3 would be herbivore and legs, this would further descend down the hierarchy into classification that will become finer and finer. The granularity will become smaller and smaller. So adding G2 herbivore here would be the next grouping set that would be considered. So we would end up in this subtree of the hierarchy here. So these are all the prehistoric animals that are mammals and are herbivores. So this is this part of the hierarchy, or all species that are mammals and are carnivores. We would end up in this particular part of the hierarchy. And of course, on the reptile half, it's the same thing. Adding another dimension, the legs dimension, would further descend down the hierarchy and make the partitioning even more fine, and we would end up in these nodes here. So this node represents the four-legged carnivores, which are mammals among the prehistoric animals that we have specified. And if you're looking at our small data set, our prehistoric table, only a single row remains, a single individuum remains here that has been classified as along this path through the hierarchy. So this indeed specifies a classification path through the hierarchy with increasing granularity, but we are starting with the ultimate coarse granularity at the root of the hierarchy, where no dimension comes into play and every fact is just thrown into one bucket. So let's see how this goes in practice. Here's the rollup query. It's actually very simply specified, and you can see that this is the path that we will follow. Starting from the root, we will first classify by class, then add the herbivore, respectively carnivore dimension to the mix, and finally we'll classify according to the legs, the bi or quadrupedality of the species. And otherwise, everything remains the same. In particular, we will still use the string aggregate here to just collect the animals that have been assembled in one particular subtree. So the string ag will collect all the values that have been found to be classified in a particular subtree of our classification hierarchy. All right, so let's perform the rollup. And what we actually expect is a fourfold grouping. A grouping according to the root, the empty grouping set, then a grouping according to class, a group according to class and herbivore, and then a grouping according to class, herbivore, and legs. That would be the four parts of the grouping that we will see in the result. Let's see whether this actually is to be found. Okay, so this is a really wide result. So let me bring down font size here. I hope that everyone can still read this. That works. Okay. Okay, so this is the result that we are getting here. And I want to highlight in particular this particular line. in which all of the grouping criteria have been set to 0. This corresponds to the root classification, in which no dimension is actually being inspected. And all the animals, in this case all the non-null animals, because the string aggregate disregards null values. All of the 6 animals, the non-null animals, have been classified according to the root. All of these are prehistoric animals according to the supercourse classification. Okay. I have reproduced the rollup result in the file of the editor above, and I've reorganized the rows and resorted the rows a bit so that you can actually see how the grouping, this hierarchical grouping, goes on. So there is a row in the result that corresponds to the root of the hierarchy, and I've just shown that to you. Then there is one step down in the hierarchy. We are partitioning according to class, and that is what you will find here. The mammals and the reptiles in their own partitions. A step further down in the hierarchy, you will find these groups. It's actually 4 groups already, where you can find the herbivorous mammals or the carnivorous reptiles, and you can see how these have been grouped. And at the bottom of the hierarchy, you will find all 3 dimensions to be relevant according to the grouping. This is the finest granularity that we can express in this particular tiny example. And you will find that according to this very fine partitioning, only a single row remains in each of these groups. This is of course an artifact of our tiny example, but it's an indicator that we exhausted all the dimensions in this particular tiny data set. So that is what Rollup can give us. Just one remark here. According to the grouping of the empty grouping, the empty criterias, the empty list of criterias, and we could actually do that in SQL without any rollup or grouping set syntax. We could just use the empty parentheses here in the group by criteria as the group by criteria list, the empty list of group by criteria. And it would behave as you would expect. There are no criteria after which we would separate the rows of table prehistoric into different groups. So every row is really thrown into one single group. One group is being constructed here, and every row contributes to it. So if we evaluate this, we will get a single group, so to say. And all of the rows, all of the non-null rows in this case, because we are using the string aggregate again, is contributing to the overall result. This is actually the same as if we would have removed the group by altogether. This is a pathological corner case, but it really fits well with the explanation of Rollup, where we gradually build up such sets of grouping criteria to build up a hierarchy of grouping sets. The final piece of syntactic sugar that aids in the specification of complex grouping is the cube modifier. Again, syntactically it plays the same role as grouping sets or rollup. It's replacement of an explicit listing of grouping criteria after the group by clause. So in a particular query, you will find something like group by cube and then a list of such grouping sets. And what this actually means is specification of a grouping sets clause in which all subsets, all 2 to the power of n subsets of these grouping criteria are actually listed in this grouping sets clause. So it's 2 to the power of n grouping queries that are specified in this very compact form. All combinations of dimensions or grouping criteria that have been mentioned or have been listed here in this G1 to Gn are being considered. So this saves us from specifying 2 to the power of n individual group by queries that we then have to glue together using union all. This this allows you to explore any subset, any slice, you could say, of the facts that you have stored. So in our example, we had 3 dimensions in which all the facts were organized, and that's something that we can conveniently specify using a 3-dimensional cube. So, and each of these individual dots here, would represent a fact that we have specified. So if we don't care for class and if we don't care for legs, so either 2 or 4 legs is fine, either mammal or reptile is fine, but we are very picky about being confronted with a herbivore or carnivore, then this is the slice of facts, the slice of data that we would extract of this cube of data points. And you can see where the name of the construct comes from. Any slicing and dimension combination that would be useful in order to group the data inside this cube, that would be considered by cube, because it just exhaustively performs grouping after all subsets of grouping criteria that you've specified in round parentheses here. Every subset will be considered, really exhaustive. So let's see this as the final example over in the editor. This is the cube. Okay, so again, very compact syntax, but quite the query that will be performed in the background for us. So let's see the result here. It's probably too wide to be properly presented in the editor. Let's see. Oh yeah, oh no, it fits, that's fine. Okay, so 27 rows already that that are being produced by this cube operation for us. We have specified 3 dimensions here, or 3 grouping criteria. So n is 3. What is actually performed in the background for us is a grouping of the prehistoric table by 2 to the power of 3, that is by 8 different lists of grouping criteria. And again, I've reproduced the group by result and reordered the rows of the group by result below here. You can have a look at this when you download the core of SQL.SQL file, and you find the grouping by all of the possible subsets of criteria, for example, by the empty subset, which again corresponds to all prehistoric animals, all thrown into one bucket. Then, of course, there is the one element subset of criteria. So we are grouping by legs only or by herbivore and class only. Here, for example, grouping by herbivore only, and then only caring for the herbivore equals truest row, this row. This corresponds to the slides on slide 43. So maybe you want to refer back from this row here to slide 43 and check that this is in fact the slice that we have formally pointed out in the data cube. Okay, so these would be the one criteria groupings, but there will of course be the 2 criteria groupings, all combinations of them. So herbivore and legs, class and legs, class and herb, and then finally a very fine classification according to all grouping criteria, and we end up with something that we've already seen in the Rollup, where all the individual species land in their individual groups. Okay, so a really exhaustive exploration of the dimensions that we have present in the prehistoric table. So much for syntactic sugar and grouping. You will find yourself using this mostly in ad hoc queries when it comes to the ad hoc analysis of data that you've just been presented with, and you will find these less being used in really large constructed queries that, but we will see that. It's still very useful and very sweet syntactic sugar in SQL. Okay, for more of that, stay tuned. See you. Bye bye.